Okay, we are solving 2375 construct smallest number from di string. You're given a zero-indexed string pattern of length n consisting of the characters I, meaning increasing, and d, meaning decreasing. A zero-indexed string num of length n plus 1 is to be created using the following conditions. Num consists of digits 1 to 9, where each digit is used at most once, and if pattern of I if pattern of I is increasing, then nums of I should be less than nums of I plus 1, and the opposite for decreasing, and we have to return the lexicographically smallest possible number. So like a few of the previous problems, this can be solved by using recursion and just like backtracking it, because the constraints are pretty lenient here. So a backtracking solution will also work. I've tried that, but there is a simpler and more time optimal solution here, which can be implemented using a stack. So it's a monostack problem. So the key thing to observe is that if you have an increment pattern, you can just append uh, the value to the result. So we can just append 1 2 3 always if you have the increment pattern. But if you have a decrement, if you have a decreasing pattern, you have to kind of store the like you have to hold the current value and then wait for the next increment, because for example in this case, so you have inserted 1 2 3 into the result, and now you're encountering a decrement. So the value that should be lexicographically the smallest is 4, right? So you have to hold on to the 4, and then maybe there was another decrement here instead of increment, so that would be 5, so you have to hold on to the 5, and then when finally the increment uh, increasing operation comes, you can then pop the results of the stack. So in that case it would be 1 2 3, and then you're holding 4 and 5, and the final value is 6, so it would be 6 5 6 5 4. Yeah. So uh, similar fashion, you can work out other examples if you're a bit confused here, but it's a good problem nevertheless. So we can have a stack, we can have a result, and then finally we are returning that result. So you're given a pattern of n length, and you have to form a string of n plus 1. So we can write a for loop like this: index comma in enumerate pattern, and we can append an I here, and this is required because in the end, if there's a pattern like this, you're only gonna pop the stack when you have an increment pattern, right? So for this kind of scenario, there, if we don't add an I to the end, there's gonna be no popping of the stack. So we add an I, and we start from 1. So for this we iterate through 1 to 10, so like from 1 to 9, and if string of I is not in result, um, we are just gonna, so if it's not in the result, we're gonna append it to the stack first, st.append, and uh, so if you have an increment, you have to pop all the elements from the stack, right? So we can run a while loop here. While stack exists, we can get the current st of -1. We can pop, so st.pop -1, or maybe not, normal works as well, and we append the current to the result array. So this should be good, and if if the character is decreasing d, you don't really need to do anything because you're already appending it to the stack before, so you can just break out of the for loop here, and that should be good enough. Let's give it a try. So sequence item expected string list form, so result, oh yeah, so here we have to append current. int found. Yeah, so current is so we're inserting the numbers into the array, so we need to convert it to string. And also, so you're just checking the if the number is in the result array, but it could be in the stack as well. So we can check if I not in stack. Okay, there we go. This is the most optimal. I think should be of n time 10n, yeah. So of n time solution. All right. See you tomorrow.